Yeah, okay. So now what is here? The value of B. The value of B gives what now here? Size of the gas molecule or volume of the gas molecule. Size of the gas molecule, otherwise volume of the gas molecule. So the value of B gives an idea about what? The effective size. Effective size of gas molecules means volume of the gas molecules. Greater is the value of B, larger is the size. Larger is the size and smaller is the compressible volume. Remember, the volume available for compressibility. The volume available for compressibility, free volume available for compression will be less. Whenever larger the size of gas molecules, suppose if you take container, in this container gas molecules are larger. So greater value of more B value, suppose more B value. If B value is more, what happens? The size of gas molecules will be larger, na? When size of gas molecules larger, when all gas molecules are larger in size, the space inside available here, this free volume available for compression will be less. So the smaller is the compressible volume. As B is the effective volume of the gas molecules, effective volume of the gas molecules, the constant value of B, the constant value of B for any gas over a wide range of temperature and pressure indicates the value of B indicates the value of B indicates that the gas molecules are incompressible. The gas molecules are incompressible. So what here, whenever larger values of B there, the gas molecule volume will be larger. That is size of gas molecules will be greater. When sizes are greater, what happens? The compressible volume available will be lesser. So that point keep in mind. Next, units of B. Okay. What is the volume correction here? Volume correction is equal to what? Volume correction. That is V dash you take. Volume correction is equal to NB. In the formula, in the equation of van der Waal, what is the equation there? P plus AN square by V square into V minus NB. V minus NB. The NB is what now here? Volume correction. The volume correction V dash is equal to NB. From this formula, B is equal to what now here? Volume correction by number of moles. Volume correction means volume in liters, na? So liters by N is number of mole. So liter mole inverse. Liter mole inverse. So liter mole inverse will be units of what now here? B. So the units of B will be what now? Liter per mole. Liter per mole. Otherwise, 1 liter, in place of 1 liter, what we can write? 1 liter means how many? Meter cube? 10 power minus 3 meter cube mole inverse. Okay, 10 power this one 10 power minus 3 meter cube, because 1 meter cube is equal to what I told you, 10 power 3 liters. 1 meter cube is equal to 10 power 3 liters. Therefore 1 liter is equal to what? 10 power minus 3 meter cube. So in place of liter, what we can write number here? In place of liter, what we can write? 10 power minus 3 meter cube we can write. So 10 power minus 3 meter cube is what? 10 power minus 3 meter cube is equal to 1 liter. That point to the mind. So 1 liter it is. So 1 liter is equal to 10 power minus 3. 10 power minus 3 meter cube. Is that clear, no? So the B indicates what here? The B indicates what? B is the size of gas molecule, otherwise volume of gas molecule. Next. So what are the units of B here? Units of B what? Liter per mole. Liter per mole. Next. The two van der Waals constants. What are they? A and B. A and B are what? The two types of van der Waals constants. The two van der Waals parameters, van der Waals constants. Okay. And Boyle's temperature. Boyle's temperature, TB, are related as. I told you Boyle's temperature. The temperature at which real gases behave like ideal gases. So what is TB here? At Boyle's temperature, real gases behave as what? Behave as ideal gases. Okay, so the real gases behave like what, ma? Ideal gases. That means the real gases start behaving like ideal gases when the temperature reaches what? Boils temperature. For every gas, there will be particular value of Boils temperature. So at the boil temperature of a gas, that gas will behave like what? Ideal gas. That is Boils temperature. So how to define Boils temperature? The temperature at which the real gases behave like ideal gases is called what? Boils temperature. So this Boils temperature formula is given by TB. Boils temperature is equal to A by RB. A by RB. Small a by capital RB. What is R here? Universal gas constant. R is what here? Universal gas constant. A and B are what? Van der Waals parameters, Van der Waals constants. So Van der Waals constants and R is what? Universal gas constant. So this TB is what now here? Boils temperature. And don't confuse with T small b here. It is boiling temperature. Boiling point, otherwise boiling temperature, we say. This is different. The temperature at which what your liquid converts into what? Gas. The temperature at which liquid changes to what? Gas. The temperature at which liquid changes to gas is called boil temperature. It is what now here? Liquid to gas. This is what now here? Boiling point, boiling temperature. But this capital T subscript capital B is called what now here? Boil temperature. This boil temperature is given by A by RB. Now here only remember that there are three types of temperatures for a gas. For a given gas, how many types of temperatures will be? The three types. So remember like this: TC, TB, TI. So remember CBI, CBI. Okay, CBI stands for what? Generally, Central Bureau of Investigation. So the CBI, keep in mind. To remember easily, remember CBI. Critical temperature, boil temperature, inversion temperature. So what is C here? C is what? Critical temperature. And B is what now here? Boils temperature. So boils temperature. What is I here? I is what? Inversion temperature. So how many types of temperatures are there here for a given gas? Three types of temperatures. Tell me what are they? Critical temperature, boil temperature, inversion temperature. Three types of temperatures. CBI. Now remember that. Already what is TB? I told you. TB formula what? A by RB. This one we understood here. A by RB is what? Formula for boil temperature. So this is A by RB. Next here, it is having, now remember about this here. It is 2 into A by RB. 2A by RB. What is inversion temperature formula? 2A by RB. Here A by RB means 1 into A by RB. Na? 1 into A by RB. Here it is 2 into A by RB. 2A by RB. That is inversion temperature formula. And critical temperature, 8A by 27 RB. 8A by 27 RB. So 8 by 27 means less than 1 or more than 1? 8 divided by 27 is less than 1. We know 8 by 27 means less than 1 into A by RB. It is 1 into A by RB. It is 2 into A by RB. So whose magnitude is greater here? Among the critical temperature, boil temperature and inversion temperature of a given gas, whose magnitude is greater? Inversion temperature value is greater than boil temperature value greater than critical temperature. So about critical temperature and inversion temperature, we are going to study. We are going to discuss about inversion temperature and critical temperature. And what is boil temperature? We discussed. Boil temperature is the temperature at which a real gas behaves like ideal gas. That is boil temperature. So about critical and inversion, we are going to study. Remember that formula now. That's all. So the formula of critical temperature of a gas, boils temperature of a gas, inversion temperature of a gas, okay, are depending on whose values here? A and B. A and B are what now? Van der Waals constants, Van der Waals parameters. A is giving idea about It is measure of what? A is measure of what? The magnitude of attractive forces between the gas molecules. B is the measure of what? The size or volume of the gas molecule. And R is universal gas constant, we know. R is constant value for any gas. R value is same. R value is same for all the gases. But A and B will be different for different gases. A and B values will be different for different gases. So the value of A, value of B will depend on nature of gas. But R is independent of nature of gas. R is same for all gases. So in terms of A and B, the formula of critical temperature, okay, Boyle's temperature and inversion temperature are given by 8A by 27 RB is the formula for TC, critical temperature. 1A by RB, that is A by RB is the formula for Boyle's temperature, and 2A by RB is the formula for inversion temperature. So these three formulae we have to remember. Okay, so about the critical temperature and inversion temperature we are going to discuss in further classes. Up to this, clear now? Next. Next one, van der Waals equation. Van der Waals equation at different temperatures and pressures. At different temperatures and pressures, van der Waals equation. First of all, van der Waals equation is given by what? P plus, tell me, P plus AN square by V square. P plus AN square by V square into V minus NB. V minus NB is equal to nRT. It is the formula for what? Real gas. That is van der Waals equation. So in this van der Waals equation, what is this value here? An square by V square is what now here? It is the pressure correction. Okay. And what is NB here? Volume correction. Okay. In some conditions, this volume correction can be neglected. Volume correction is neglected, meaning what? V minus NB, we write V only. When volume correction is neglected, suppose under some condition, what we take? V minus 0, that is V. And in some cases, An square by V square, that is pressure correction will be neglected. In some conditions, pressure correction will be neglected. When pressure correction is neglected, it becomes 0. Then P plus 0, P only. Is that clear, ma? So P plus An square by V square will be taken as only P if pressure correction is neglected, and V minus NB will be equal to V if volume correction is neglected. If volume correction is neglected, we take what? V minus NB as V. If pressure correction is neglected, what we take? P only we take in this place. That means what now here? Suppose if we take extremely high pressure, suppose the pressure of gas is very high. When pressure of the gas is very high, in comparison with high pressure, this pressure correction can be neglected. When pressure of the gas is very high, what can be neglected? This pressure correction can be neglected in comparison to very larger pressure, high pressure. Next, when we neglect this volume correction is that if the volume of given gas is very large, if volume is very large in comparison to very large volume, this volume correction can be neglected. When we neglect volume correction, if volume of gas is very large. When we neglect pressure correction, if pressure of gas is very large. Tell me now conditions here. When what we neglect at what time? If pressure of gas is very high, what will be neglected, ma? Pressure of gas is very high. An square by V square can be neglected. An square by V square can be neglected. When you neglect An square by V square, tell me what happens? This An square by V square, suppose we neglected. Then a P plus this one, P only. Okay. Next, when we neglect the volume correction, if volume of gas is very large, if volume of gas is very large, when volume is very large, what happens, ma? Volume correction. Volume Volume correction is what now here? NB. Volume correction is what? NB. Can be neglected. NB can be neglected. So when you neglect NB, V minus NB, we take V only. Is that clear, ma? In some cases, pressure correction will be neglected. In some cases, volume correction will be neglected. In some other cases, both volume correction will be neglected, pressure correction will be neglected. Suppose you take H, extremely low pressure of gas, and very high temperature, very extremely high temperatures. So extremely high temperature and low pressure. So according to Boyle's law, volume is inversely proportional to pressure. When pressure is very low, volume becomes what? Very large, na? Volume becomes what? Very large. So volume becomes very large means if volume of gas is very large, what can be neglected? Volume correction can be neglected. Like that, here, very low, very high temperature we have taken condition, very high temperature. We know that V is directly proportional to temperature, Charles' law. Volume of gas is directly proportional to temperature. When temperature is extremely high temperature, volume also will be very large, na? At extremely high temperature, volume is very large. At extremely low pressure also, volume is very large. So at extremely low pressure and very high temperature, what happens? Volume becomes very large. Volume becomes what? Very large. When volume of gas is very large, what happens now? What can be neglected here? Volume correction can be neglected. And also what we have to understand is that now pressure is extremely low now. At extremely low pressure, we can also neglect what now here? The pressure correction also. Pressure correction can be neglected. Volume correction both can be neglected at extremely low pressures and high temperatures. That is why at extremely low pressure condition and high temperature condition, all the real gases behave like what? Ideal gases. Then real gas equation becomes what? Ideal gas equation. This total real gas equation becomes what, ma? Ideal gas equation. Tell me. So this total real gas equation becomes what? Ideal gas equation under what conditions? At extremely low pressures and extremely high temperatures. Okay. So the volume of the gas becomes very large and hence volume correction can be neglected. Okay. And also pressure becomes very low and pressure correction can be neglected. Suppose you see, if volume is large, the between one gas molecule, other gas molecule distance becomes very high, na? If gas volume is large, suppose if volume of the gas is large, what happens now? The distance between one gas molecule. So when volume is very large, what happens now? It is one gas molecule, When gas molecules are away from each other, this attractive force between the gas molecules will be very low A value. Very less value of A will be there. Why A will be less here? Attractive force less, na? When volume is large, the gas molecules will be moving away from each other. When gas molecules move away from each other, the attractive force will be less. When attractive force is less, what happens? The pressure correction is what? AN square by V square. The pressure correction is directly proportional to A. If value of A is very low, what happens? The pressure correction becomes very low. So pressure correction value becomes very low in comparison to what? Pressure. That's what pressure correction also can be neglected as A value becomes very low. When volume is very large, the attractive forces will be very less. When attractive forces are very less, the pressure correction becomes very less. And hence, pressure correction can be neglected. Volume correction can be neglected. Pressure correction can be neglected at what? At extremely low pressure and high temperature. Then what happens now? This becomes only P plus 0. P only. Here V minus 0, V only. So P into V, PV is equal to energy. So in this condition, what happens now here? The PV is equal to nRT. That means what now here? The real gas equation becomes what? Ideal gas equation at extremely low pressures and high temperatures. So that point mainly keep in mind. Okay. So these conditions we have to understand here. So about this condition, we are going to discuss in the next class. Okay. About this, we'll discuss later. Is that clear, ma'am? Today only go through once real gas equations concept. Any reference book. Take any one reference book and go through that, please. Okay. Without wasting time, read all the things. Very important.